So in this video, we're going to pick up from where we left off in the last, and we're going to look at how can we extend the system so that instead of just pathing between two set points on the landscape, we can draw any number of paths across it and have the find shortest path algorithm sort of deal with those multiple user-defined curve inputs. But before we do that, let's just go and have a little play with our graph and sort of organize it up into sort of logical sections, which will help us start to think about how we might break this into a set of digital assets in a kind of more modular way. So to begin with, we have our height field inputs, and we're sort of processing the height field for the shortest path algorithm. So we're going to call this section prepare height field. Then we have our user input section, user input curves. And this little section here, it's kind of operating on the prepare height field. I'm not sure whether I would want to include that costing with the preparation of the height field, though. I think that we probably want to handle the costing in the actual pathfinding algorithm. So I'm just going to group this section anyway and call this calculate costs. And then we've actually got the pathfinding. This sort of stands alone as a single node, so we can just leave that as is. And all of this stuff just below here is sort of under a kind of a visualize output. So this doesn't actually affect the end result in any way or process the geometry. It just is allowing us to visualize it in a couple of different ways. And I'm going to actually just cut out that attribute normalize float and paste it in on this line over here instead, and call this visualize costs. So there we go. We have our sort of preview. We have our kind of heart of the system here, which is the shortest path algorithm or node. And then we have our sort of preparation of the height field here on the left-hand side. Okay, so let's go and create a new user input, which is going to be another curve. And let's wire that in place of the old one, the first one. And by default, we can see that we don't get any result. But if I click on this curve node and press enter, whoops, that's not what I meant to do. If we click on this curve node and then click back in the viewport and press enter, here we go. We can see that we've now entered the curve editing tool again. And if I just click once and then twice somewhere else, we get the pathfinding algorithm behaving the way that we intend it to. But if I go and click another point over here on the train, we can see that the find shortest path algorithm is still only routing between points 0 and 1 of that curve that we've just drawn. So if I hit enter to complete the curve, we just want to look at how can we extend the system so that it's able to handle a curve input that has more than 2 points. And we can verify, in fact, if we preview that curve now and turn on the point number preview, we can see it's 0, 1, and 2. And this gives us a clue about where the issue lies. So I'm hitting escape to exit the tool now, so I'm no longer in the curve editing mode. And I'm just going to hit Alt and backslash to pop up my parameter window with the curve tool selected again. And I'm going to select the find shortest path node, and we can see that at the very top of the parameter interface, we have our start and endpoint specified. And right now, we're only routing from point 0 to point 1. If we switch back to the output tab, we can see that the output paths option that we've selected is from each start to each end. So that means if we plug in 0 to 1 and 2, and then have a look at that output, I'm going to turn off the point number preview, we can see that it's now routing from point 0, which is over here. If we remember, that's the curve that we drew. Point 0 is over there, 1 and 2. So what it's actually trying to do right now is it's routing from point 0 to point 1 and from 0 to point 2. So we can play around with how this works, because we could say also we want to go from point 1 to point 2. This is actually now introducing some redundancy because it's also routing from point 1 to point 1, which obviously means it can't do anything. And if we actually plugged in 0 here now, we are seeing a different color because we're getting a path in a different direction. So that's actually what's changed there. It's actually now we've got two primitives, sort of one going in one direction, one going in the other. So hopefully we can see that this mode from each start to each end isn't what we're looking for. We're looking for a way of taking the user-defined curve input in the order that it's been drawn out and sort of saying we want to go from point 0 to point 1 and then point 1 to point 2 and so on. And the setting that we want to use on the output paths here isn't from each start to each end, it's from each start to each corresponding end. And straight away we're going to get an error. You might not get an error. And the reason I'm getting an error is, let's have a little look, see what it says. is because when going from each start to each corresponding end, let's drag that up, the number of start points and end points must be equal. We can clearly see that that's not the case. So let's clear those again. We'll get rid of our error, but clearly we don't have any paths because none have been defined. But let's just go ahead and say from point 0 to point 1, and now we're back where we started. Only this time, we want to carry on from point 1 to point 2 as well. So if we add point 1 to the start points, and we add point 2 to the end points with a space separating them, we now have basically said go from 0 to 1, then 1 to 2. So imagine it's sort of like reading from left to right and top to bottom. We're going to go top to bottom, then we're going to step over, and then we're going to top to bottom again. So that's kind of like the order. This is the path start, path end, and then this is the next step. And it's really that simple. So if we go back to our curve, we go back to the editing mode by clicking on the viewport and pressing enter, and then left click somewhere else. Oh, I've actually made a mistake there. So what I've done is sort of the next step, because we've started drawing a second curve. So I don't want to do that. I'm just going to go ahead and hit Control Z to undo that curve. So before I click again, I actually need to click on the end point that I want to start from. There we go. And now I can just continue that curve on over here by left clicking somewhere else. And clearly now, if we go and preview that curve, we can see we have points 0, 1, 2, and 3, which means if we wanted to continue routing, turn off the point number preview from the end of our section there, we would actually now need to go to 3. Okay, so now we can see that this is basically how we need to fill out these two groups in order to handle any number of curves. And I did actually touch on another issue there, which is if we go back to the curve 2, and without sort of clicking on one of the existing points on the control curve, and we just start by left clicking somewhere else and left clicking again to draw a new curve, that's actually going to create a whole disconnected separate path that we also want to be considered in the pathfinding algorithm. You may not want it to work that way, but I think that's the way that I want it to work, and it sort of feels the most intuitive to me. Is you draw it out, you expect the pathfinding algorithm to consider it, even if they're not connected. So the issue being, of course, that we aren't automatically sort of extending the curve whenever the user creates sort of a new user input. So let's go ahead and figure out how we can deal with this issue, focusing first on extending the single primitive, sort of following a single drawn curve by the user, and then looking at how do we handle those sort of disconnected curves as well. And the way we need to do this is by dynamically populating the two groups on the find shortest path node. So we need to dynamically populate this start points list, and we need to dynamically populate this endpoints list. And when we're working with lists commonly, we're thinking in terms of arrays. So you might have an array of integers, which is just a list of integers. In this case, the groups are actually strings. So if we go to edit expression, we can see that it would be edit string. So we're not going to be thinking of creating an attribute array. We're going to be thinking of creating a string, which is just a space separated list of all of the paths. Of course, it will be helpful inside of, however we are creating these lists, it's probably going to be helpful to think of doing that in terms of arrays to begin with. And there's a few ways that we could do this, but the way that I'm going to do it is, actually, let's have a little play first of all and look at what we get with an attribute promote. So an attribute promote just allows us to convert an attribute to a different, if it's a point to a different sort of, how would I describe that? A different class. There you go. It even says it there. So we're going to go from point to detail. And if we do that, it actually allows us to do an array of all. So let's right click on the promote and go to the spreadsheet. And then let's go to the detail attributes. And I'm just going to type in point num and see what happens here. And I have a feeling that this isn't going to work. Yeah, okay. Because point num isn't actually an attribute. I think it's an intrinsic. So that's not going to work. I just thought I'd try that out as a little experiment there. Just to sort of tell you, actually, if we go attribute create, sort of show how this would work, we can set up a attribute called number. We can have it be a point, we can have it be an integer, and then we could set, I think, the value, that's not what I meant, the default, the value to be equal to @pointNum. And then let's have a little look, see if that did work. Yep, there we go. So now we have a number attribute on our points, which is corresponding to the point number. And then if we did the attribute promote of num instead of point num, because that's now actually an explicit attribute, we can create that array. But of course, This is an array and it's not a string. So we would then need to sort of further process this list somehow. And we actually need to create two lists which are not identical, because we want to create a sort of a slightly offset list where the start point starts from point 0, but the end points starts at point 1. The start points finish at the second to last point, and the end points finish at the very last point. So even having this array, we're still going to want to process it further. So let's ditch the SOPs way of doing things and just jump into a simple wrangle here. I'm going to throw down attribute wrangle. And in this case, what we can be thinking, one way to sort of think about what we're doing is we're sort of collecting attributes from the points, and we're sort of concatenating those attributes into a single list that exists just once for the whole geometry. So we're going to be wanting to create a detail attribute. So I'm actually going to make this wrangle be a detail wrangle, which means that the code inside of this expression isn't going to run per point. It's just going to run once for the whole geometry. Okay, so this is our wrangle. And we're just going to go ahead and sort of recreate that attribute that we had before, which was that list of point numbers. So we can create an integer array of points. There we go. So that's how we do that. And those points are going to be, we can find those points by using the function expand point group. Okay, so this lets us find all of the points inside of a point group. It's the first input of the wrangle, so we're going to use index 0. And then the group, if we just have a little look at the comment there, we can see that the second input to the function, or the second parameter of the function, is the group name. In this case, we don't actually have any groups. We just want to get all of the geometry, and it's a string. And if we just leave that string empty, that means it's going to grab all, as in that's the group of everything. Okay, so we have our points array, and we could actually say now array points equals points, like so. And if we now look at our geometry spreadsheet again, we can now see that we've created that array of points as a detail attribute. Okay, so we could call, okay, that was just a preview actually, the array, now we've promoted it. So we've just recreated those SOP functions we did earlier. So we don't want this to be an integer array. We actually want it to be a string. So we could say s at list a, because all start points. Let's go s at start points equals, we can just see what happens if we do points. And we're going to get an error here, which is going to tell us that we can't just cast, we can't just convert it from an integer array to a string. So we're going to have to basically do that conversion from that array to the string. And one way that we can do this is using the sprintf function. So actually I'll just clear this up so we can see the tooltip. So we can see that we're going to format the string like printf, but return the result as a string instead of printing it. So if we actually want to see a bit more information about what's happening here, you can look at the printf function, and this is going to give you some useful tips on how those conversions are going to happen. So what we're going to do is just go sprintf, there we go. And then I'm going to use the sign %g. I might actually need to be inside of the quotation marks, but I can't remember. And we're going to go do that on points. Okay, so we're going to look at the geometry spreadsheet once more. And we see that we have our integer array of points. There we go, in that list there. And then we have our string, which has just taken that array and formatted it as a string, keeping all of the sort of the signs between all of the numbers, which we want to get rid of. So we want to remove the curly braces and we want to remove the comma. So one way we can do this is we can just use the replace function. So we can replace inside of a string a certain token with another token. And I'm not just going to do this on the attribute here because I just want to basically operate on sort of internal variables within Vex and then output them to an attribute. So we're going to initialize a variable called string a. Just for simplicity's sake, I don't really care about naming because it's only going to be a simple vex expression. And string A is going to be that result from the sprintf that we did there. And then we're going to set start points to be equal to string A. Okay, so we get no errors. This code is all fine. And then we're going to run on A, we're going to run that replace function. So we're going to replace within A the string curly brace with an empty string, like so. And we're also going to do that on the reverse curly brace, like so. And we're also going to do that on the comma, like so. Okay, and just have a little quick look at the result. We can see that that hasn't worked, and it's because we actually do need to set A to be equal to that result. Okay, so now you can see that we've formatted this string correctly. It starts at point 0 and goes up to point 8, so it's every point in that list. Now we also need to create the endpoints array or endpoints list. So we're going to make a new string attribute called endpoints. We're going to be setting that equal to B, which means that we will get an error because B doesn't exist. So then we can say, after that replacement has happened, B equals A. Okay, but we do need to make sure that we're declaring the type. So now we have our two lists. We no longer need this points array there, so we can get rid of that attribute. So we now have our two lists, and we're basically there now. The only remaining issue is that right now we're trying to route from point 0 to point 0, point 1 to point 1, so we're not actually telling the pathing to go anywhere or do anything. Which means we just want to remove the first, we want to remove point 0 from the endpoints, and we want to remove point 8 from the start points. So the way we can do that is we can just add an additional little argument to the string B equals A here. We're going to say that we actually want to go from the first sort of argument. We want to exclude index 0 of that string. We can see that we've actually still got some white space here. So because we're dealing with white space as well, and that's counted as an index of the string, we need to go to 2, so saying 2 all the way up until the end. But this now means that our endpoints array is shorter than our start points array. We just need to go and modify our endpoints array as well. So A is going to be equal to A, using a very similar kind of idea. I'm going to say, okay, well, we want to keep the first index this time, the very first entry in the string, but we want to get rid of the last one. We can use that by saying -1 there, 0 up to -1, forgot my semicolon. And now we can see, in fact, we have the two lists that we want, but I'm just going to go and double check this string and see if we have any white space at the end, and we do, and we want to make sure we get rid of that white space too, so we can go -2. And we see that visually the result hasn't changed, only this time if we go in and inspect that string once more, we no longer have the white space at the end. So we have our two correctly formatted lists called endpoints and start points, which means that if we go to our find shortest path node, we can now put those in as arguments here using a little bit of HScript. So we can say details, or in fact, in order to get this to show up properly, I can use a little backtick there. And if we can now go details, the S is for the string. That's why we're not just using the detail argument. Details, and we want to get the first index here because it's the second input to the find shortest path node, and the group that we want, or the attribute, sorry, that we want is called start points, like so. Remember to close that with a backtick as well. Now we middle mouse and click on start points, we can see that that is getting the correct values from the attribute. So we can just copy that argument for the endpoints and put in the argument endpoints there for the attribute name endpoints. And we should now be able to see that if we look at the end, we're getting something. Now this looks a little bit messed up, and I'll give you a couple of seconds to guess why. Now, if you remember earlier, I said that we'd first deal with figuring out how to continue a single continuous curve segment and deal with this discontinuous kind of separated curve segments later. Then you are correct. We are not considering the fact that these two curves are separated right now. So I'm just going to go ahead and click enter in the viewport to enter the curve editing mode. I'm going to go and middle mouse click on the point in the middle there, and I'm going to hit delete points. And I'm going to grab the same one at the end and delete those points too. So now we're just left with this single connected curve. If I hit escape, you can go back and look at the output of the find shortest path node, and we can see that indeed we are getting that path going all the way from point 0 along the curve to point 1. And I'm going to go and create a new curve so we can watch this all happening interactively, make it all sort of feel a bit more responsive. So with the curve node selected in the viewport, I hit enter, and then I just left click again. And you can see we have this really nice ability to go and dynamically create paths. And if you leave a longer gap between the points, you can see that the path finding algorithm is a little bit more free to do what it wants. But I can then sort of hit enter to complete that edit there. But if I then control click in the middle, interestingly, it has actually created a whole new point. So I would have thought that inserting a point would sort of reorder that there. And that gives us a little clue. We need to go and do one more thing because we want to make sure that the point numbers actually make sense. So, the pathing I would expect to go this way instead of doing it sort of thing over there. So just to ensure that if we add points later and they get sort of correctly ordered, I'm just going to go and throw down a little resample node. I don't want to get all of these points, so I'm not actually going to do any resampling. I'm going to turn off maximum segment length, and I'm just going to say resampled by polygon edge is equal to true. So now you can see that whereas before it's going 0, 1, 2, 4, 3, now it's been reordered into 0, 1, 2, 3, 4, which is what we want. So let's have a little look. And now if we go back and sort of modify our curves, you can see that it is actually pathing kind of correctly. And when we see these sort of little bits here where it's sort of appearing to be just one path that sort of goes off from the main trajectory there, it's because it's actually cheaper to go this way and backwards in reverse to go back this way. And we could go and sort of modify that and ensure that this gets broken up a little bit more by just creating a new point over there. And you can see as we pull that away, it's going to sort of do a different thing. We can add a new point in over here to force the pathing to go there. So there we go. We've created our sort of first sort of interactive drawing of these height field paths, but we still haven't dealt with the adding sort of discontinuous sort of separated curve segments because they get connected up to that one path. So we need to deal with that next.